Hello and welcome back. In the last lesson we talked about how to solve a system of linear equations. We established that in order to solve a system of linear equations, we need to graph two different lines and find their point of intersection, or solution. Now, we don't always want to have to graph two different equations in order to find their point of intersection. It'd be a lot easier if there was another method that didn't require graphing, and that is the method we're going to be going over in this video. It is called substitution. So let's consider two different equations. Y is equal to x plus 1 and y is equal to negative 2x plus 4. Normally what we would do is graph the first equation and graph the second equation, and notice that their point of intersection is 1, 2. So we would label the point of intersection, then state that the point of intersection or solution is 1, 2. So that's normally the way we would go about approaching it. Now, there's another method that we can use, and as I said, that method is called substitution. So the first step we're going to do, if both equations are given in point-slope form, is to just say that y is equal to y, because we know that's true. So if y is equal to y, we know that y is given by x plus 1 from the first equation, and it is given by negative 2x plus 4 from the second equation. And once we do this, our main goal is to solve for x. And we talked about that. We talked about how we can rearrange terms and isolate for x using different techniques and strategies. So I'm just going to start off by rewriting x plus 1 is equal to negative 2x plus 4 over here. So the first step is going to be to move all the x terms to one side. So we can either subtract x from the left hand side or add 2x to the right hand side. We are going to add 2x to the right hand side like this. That means we have to add 2x to the left hand side. Negative 2x and 2x cancel out. That means we're left with x plus 2x plus 1 is equal to 4. X plus 2x is 3x. That gives us 3x plus 1 is equal to 4. And from here we just need to isolate for x. The first thing we're going to do is get rid of the 1. We are going to subtract 1 from the left hand side, which means we must subtract 1 from the right hand side. Plus 1 and negative 1 cancel out. That gives us 3x is equal to 4 minus 1, or 3x is equal to 3. And now we have to get rid of the 3 next to the x. So we divide the left hand side by 3. That means we have to divide the right hand side by 3. 3's cancel out and we're left with x is equal to 3 over 3, or 1. So that's it. X is equal to 1. And again, we already went over how to deal with an equation like that. So this is kind of extra practice and building up on our ability to solve for x given different linear equations. Once we do that, all we have to do is plug x is equal to 1 into either one of the equations. I'll plug it into y is equal to x plus 1 because that's a lot easier. All I'm doing is adding 1. So we have y is equal to x plus 1. If I use x is equal to 1, that gives 1 plus 1, which is 2. So you get y is equal to 2. And therefore, your point of intersection, or solution, is 1, 2. And that's your final answer. So that is an example of how one would use substitution to solve a system of two linear equations without graphing. I'll do one more example. In this example, we have one equation in point-slope form and another in standard form. So how would we deal with that? Well, the idea is going to be to substitute y is equal to negative x minus 2 into the other equation. So we have 4y minus 2x is equal to 16. And I want to substitute y is equal to negative x minus 2. So that means I'm going to substitute negative x minus 2 for y. And once we do that, all we have to do is solve for x. So we can start off by distributing. That'll give us negative 4x minus 4 times 2 minus 2x is equal to 16. And then we have that 4 times 2 is 8, so we have negative 4x minus 8 minus 2x is equal to 16. negative 4x minus 2x is negative 6x, so negative 6x minus 8 is equal to 16. Okay, I'll write that again over here. Then from here, we're just trying to isolate for x, or solve for x. We can add 8 to the left-hand side, and that means we have to add 8 to the right-hand side. Negative 8 and plus 8 cancel out. You're left with negative 6x is equal to 16 plus 8, or negative 6x is equal to 24. You divide the left-hand side of the equation by negative 6. That means you have to divide the right-hand side of the equation by negative 6, because again, we're trying to isolate for x. Those terms cancel out, and we're left with x is equal to 24 over negative 6, or negative 4. So that's our x value. X is equal to negative 4. And again, all we have to do is substitute x is equal to negative 4 into either one of the equations. So I'll substitute x is equal to negative 4 into y is equal to negative x minus 2. That means that x is replaced by negative 4, and you're left with negative 4 minus 2. That is 4 minus 2, which is 2. So we have y is equal to 2. For x is equal to negative 4, y is equal to 2. Therefore, our point of intersection, or solution, is negative 4, 2. And that is our final answer. And if you were to graph these two equations, you would indeed find that they would intersect at the point negative 4, 2. So that's all I want to go over for this video. In the next video, we'll go over another technique that can be used to solve systems of linear equations. And that technique is called elimination. But for now, as always, thanks for watching.